Hello students, welcome to H&J Online Academy. So today we are looking at differentiation. Okay, so when we say differentiation, differentiation is the same as gradient. If we are differentiating, we are finding the gradient, right? So for example, given y is equals to a x to the power of n, right? So gradient is equals to, gradient is written in the form dy over dx, which is equals to, we bring n down and that n will multiply with a, so we have a n, then we subtract 1 from the power, so we subtract 1 from n, so we get n minus 1. That's how we differentiate. So if we differentiate y, we get dy dx, right? So dy dx means we are differentiating y with respect to x. That's when we get dy dx. Then if we differentiate a x to the power n with respect to x, we get a n x to the n minus 1, right? That's how we differentiate. So first example, given y is equals to x to the power of 8, right? So if we differentiate y here with left hand side with respect to x, we get dy dx. So dy dx, which means the same as gradient, is equals, we bring 8 down and subtract 1 from 8 to get 8x to the power 7, right? That's our gradient, right? So our next example, y is equals to 3x squared minus 4x plus 4. So it is easy now to find the gradient, because now we know how to differentiate, how to find dy dx. So it's easy. We say if we differentiate y with respect to x, we get dy over dx, which is equals to, we bring 2 and multiply 2 with 3, get 6x. If we subtract 1 from 2, we get 1, so we get 6x minus the power here is 1, so if we bring 1 will multiply with negative 4 to get negative 4. Then x, if we subtract 1 from the power, 1 minus 1, we get 0, so x to the power 0, which is 1. 1 times 4 minus 4, we get minus 4, right? So here we have x to the power 0. If we multiply 0 times 4, we bring 0 down, so 0 times 4, we get 0, and subtract 1 from the power, still we get 0 to the power something. So it implies that if you differentiate a constant, you get 0, right? If you differentiate a term with x to the power of 1, you get constant. It's simple, right? Okay, so y is equals to 8 root of x, right? So 8 root of x is the same as 8x to the power half, so x to the power of half, right? So after that we differentiate now, because we can't differentiate here before simplifying like this. So after we simplify, we differentiate now. We can go. So if we differentiate y, we get dy over dx, which is equals, now we bring down the power, so 8 times half, we get 4. Then we subtract 1 from the power to get x to the power half minus 1 to get minus 1 over 2. So this is our derivative. This is our gradient, in other words the slopeness of the curve or the equation. So after we have differentiated the equation of the straight line, we get the gradient of the straight line. After we have differentiated the equation of a curve, we get the gradient of the curve. So the derivative is the same as the gradient, right? So you can simplify further to say dy dx is equals to 4 over x to the power of half laws of indices, which is the same as 4 over root of x. It's simple, right? So differentiation is so simple. So next example. Okay, so last example, we are given the curve, the equation of a curve y is equals to x plus 2 and x minus 7, right? So the question, if the question asks you to differentiate this a curve, to find the gradient or the slopeness of this curve, you start by expanding the brackets. So after you expand the brackets, you have y is equals to x times x squared, x times minus 7x plus 2x minus 14, which will gives you x squared minus 5x minus 14, right? So after that we can go now, we've simplified, so we can now differentiate. So if we differentiate y, we get dy over dx, right? We get dy dx after differentiating y with respect to x, right? But if we differentiate x squared with respect to x, we don't get dy dx now, because we are differentiating with respect to x, right? Now here on left hand side, we get dy dx because we are differentiating y with respect to x, right? So if we differentiate x squared, we bring down 2 to get 2x, right? 2 minus 1 is 1, so x to the power 1 is the same as x, right? Now if we differentiate minus 5, we get minus 5x, we get minus 5. Then if we differentiate a constant, we now know if we differentiate a constant, we get a 0. So this is our derivative. This is our derivative. So if you differentiate this curve, you get this derivative of this curve is this one. So this is our gradient, right? So the gradient of this curve, if when x is equals to 2, it's different from when x is equals to 4. So this is the general gradient. It differs from point to point. So when x is equals to 2, we get the gradient when x is equals to 2, because this is a curve. This is a curve like this one. This is a curve. So the gradient is different from each point to another point. For example, when x is equals to 2, let's say here, the gradient here, if we put it 2 times 2, we get 4 minus 5. The gradient here is 1, right? So when x is equals to 4, say 4 is at this point. So when x is equals to 4 times 2, we get 8 minus 5, we get 3. So gradient at this point is equals to 3, right? So this is the general gradient of the curve, right? So that we will know the gradient at a particular point if we have that point, right? So given a point and given a curve, you can find the gradient of the curve at a given a point, right? So it's simple, right? Next example. So now the question is asking us to find the gradient of the following points indicated, right? We are given at item A, y is equals to 5x minus x squared. So we are required to find the gradient of this curve at point 1 and 4, right? So we start finding the gradient. So the derivative right? If we differentiate this curve, I'm sure everyone is now able to differentiate. So dy over dx is equals to, you get a constant here, 5 minus 2x, right? So this is our general gradient. This is the derivative. So we want to find our gradient at this particular point 1 and 4, right? So when x is equals to 1, because this one is the value of x now, so we want to find the gradient at the point when x is equals to 1, right? So that point y, we cannot use it in this case, because we want to replace x here by the value of x to get the gradient at this particular point, right? So dy over dx is equals to 5 minus 2 open bracket. We substitute x with 1 here, because this is the x coordinate, 1, which is equals to 5 minus 2, which is equals to 3, right? So gradient of our curve at this particular point is 3. So if you calculate the gradient of this curve at some particular points, you will see it will be different from these 3 at this particular point, right? Say for example at the point 2 and 4, right? The gradient at this particular point will be 5 minus 2, we replace x by 2 now, so 5 minus 4, which is 1, right? So the gradient of the curve differs from point to point. Simple, right? Okay, so item B, we are given the equation of a curve y is equals to 2x squared minus x plus 4 over x at this points 2 and 8, right? We are required to find the gradient at this particular point, So we'll start by differentiating the curve. So we can't differentiate at this stage, right? We have to simplify the law. We apply the laws of indices here. So 2x squared minus x plus 4 to the power 4x to the power minus 1, right? That's how what we get if we apply the laws of indices here. Then now we can differentiate. We can go now. So dy dx is equals to, now if we differentiate here, we get 4x. Then if you differentiate minus x, we get minus 1. Then now how we differentiate, we bring down this minus 1. So minus 1 times minus 4, we get minus 4. Then we subtract 1 from the power. So if we subtract 1 from minus 1, we get minus 2. So minus 1 minus 1, we get minus 2. So this is our derivative. So we want to find the gradient at this particular point when x is equals to 2. So when x is equals to 2, we substitute 2 here. So 4 times 2 minus 4 minus 1 minus 4 open bracket 2 here to the power minus 2, right? 4 times 2 is 8 minus 1. Then here is 1 over 2 to the power 2 if you apply the laws of indices, right? So minus 4 times 1 over 2 to the power 2 is minus 4 over 4, which is minus 1. So 8 minus 1, we get 6, right? So this is the gradient of this curve at this particular point, right? So this example now, find the coordinates of the curve y is equals to x squared minus 4x plus 5, where gradient is equals to 2, right? So now we know the gradient is equals to 2. So we want to find the coordinate of the curve at where the gradient is equals to 2. So what we need to do here, what we are required to do is to find the derivative of this curve. After we find the derivative of this curve, we equate that derivative to 2 to find the coordinates of the curve at where gradient is equal to 2, right? So if we differentiate here, dy over dx is equals to, bring 2x, then if we differentiate here, the power is 1 times get minus 4, then 1 minus 1 get 0, x to the power 0 is 1, right? So if we differentiate the constant, we get 0, right? So we now know that our derivative is 2x minus 4, our general derivative. So we are given that the gradient is equals to 2, and this is our gradient, right? So we just have to equate the two gradients here. So 2x minus 4 is equals to 2, because this is the gradient of the curve and this is the gradient of the curve. So we want to find the value of x. Now it's simple to make x the subject of the formula. It's simple. So 2x is equals to 2 plus 4, which is 6 if we bring minus 4 to this side. Then we divide both sides by 2, so x will be equal to 3. Simple. So this is the value of x, right? So we want to know if x is equals to 3. If x is equals to 3, we want to find the value of y if x is equals to 3, so that we come up with the coordinates of the curve. So if y is equals to, we go back to our original curve, then we replace x by 3. So 3 squared minus 4 open bracket, we put 3 plus 5, right? It's simple. So we get 3 squared is 9, then 4 times 3 is minus 12 plus 5, which is equals to 9 minus 12 is minus 3 plus 5, which is equals to 2, right? So now we have the value of y, we have the value of x. So we have our coordinates now. So our coordinates are the coordinates are written in this form: 3 started by the x coordinate, 3 and 2. That's our coordinates. So the question was asking us to find the coordinates of the curve, this curve, where the gradient is equal to 2. So we just calculated the gradient and equate this gradient to the given gradient, which is 2, to find the value of x. So after we obtain the value of x, we go to the original curve, we replace x by 3 to get the value of y. So if we have x coordinate and y coordinate, so we have our coordinates. I think it's simple. Okay, so before we go any further, I may want you to know this, guys. The equation of the curve may be given in the form y is equals to x squared plus 4x, right? So we have been dealing with this kind of equation. So it may be given in another form, say f of x is equals to x squared plus 4x, right? This is the same as this, but now it is given, this means function of x, right? Which this is function in terms of x, right? So if we want to differentiate this equation, we get dy over dx, which is equals to 2x plus 4, right? If we differentiate y, we get dy dx. But now if we differentiate f of x, we get f prime of x, right? We get f prime of x, but the derivative will not differ from that one, 2x plus 4, right? So you have to know all the cases. Sometimes you are given the equation in this form, you have to know how to differentiate, don't say dy dx is equals to, if you are given in this form, you say f prime of x, right? That's how you do it, right? So here is the example, right? So this is quite different from previous ones. In this case, we are given this function. If f of x is equals to x cubic plus 1, find the value of a, given that f prime prime of a is equals to 24. F prime prime, which means the second derivative, right? The third derivative is f prime 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 of a, so the second derivative f prime prime of a, right? Then if the question is in this form, y is equals to, the first derivative is dy dx, then the second derivative is d squared y over dx squared. The third derivative will be d cubic y over dx cubic, right? So and so on. So here the first derivative is f prime of a, the second f prime prime of a, right? So we are given f of x is equals to this, but we are not given f of a. So if you did functions, you know how to simplify this, the composition of functions, right? If we given f of x, we can find f of a. So f of a, we know f of x, right? So f of a, we have to replace x here by a, because we have a in place of x. So on the right hand side, we have to replace x by a, so that the equation will balance. So f of a is equals to a to the power 3 plus 1, right? A to the power 3 plus 1. This is f of a now, right? So we are given that f prime prime of a is equals to 24, and we are required to find the value of a. So it's simple. We just have to differentiate. So we find the first derivative and find the second derivative and equate the second derivative to 24, so that we find the value of a. Simple here. So f prime of a, which is the first derivative, is equals to, we bring down 3 to get 3a, you subtract 1 from the power to get 2. Then if we differentiate 1 is the constant, so we get 0, right? Then we go on and find the second derivative, which is f prime prime of a. So f prime prime of a is equals to 2 times 3, bring 2 down, get 6a. 2 minus 1, we get 1. So a to the power 1 is the same as a, right? So the second derivative is equals to 6a, but we are given that f prime prime of a is equals to 24. So we just equate this second derivative to 24, right? So 6a is equals to 24, right? If we divide by 6, both sides over 6, divide by 6, we cancel with 6 here. So a is equals to 6 into 24, we get 4. So a is equals to 4, right? It's simple. Okay, so we are going to end this lesson here. We are going to cover the derivative of ax plus b to the power n in the next video, right? So guys, don't forget to subscribe and like to our channel. We also have another channel called Mass Vibe, MASSVIBE. We do some tutorials on pure mathematics, so you can just type Mass Vibe on YouTube, then you can enjoy mathematics. Okay, so feel free guys to ask questions if you face any challenges when differentiating any type of curve or straight line. if you face any challenges in finding the derivative of any curve, any straight line, feel free to ask question. We will respond to you guys. So we're going to end here. Thank you guys for watching.